So here we go. First thing I'm going to do is go ahead and factor right from the beginning. I notice nothing cancels, so I will not have any holes in my picture because nothing canceled out. However, I do have something in the denominator, so I will have a vertical asymptote at x equals 2. Now what about my end behavior asymptote? A lot of times those are horizontal lines, but not this time, because why? The power on the top is bigger. So what do we do when the power on the top is bigger? We divide. Yes. So what is my end behavior asymptote? Y equals x plus 5. So I'll graph that over here. So there is my end behavior asymptote. No holes. Zeros. Does this curve have any zeros? Are there any numbers that would make this zero?
Yeah.
2 of them. -4 and +1. X-intercepts. How do I find x-intercepts? I let that be 0. Now what about y-intercepts? Well, if I put 0 in, it looks like I get 2. So that's it for all the important stuff. So at this point, what do I need to do? Figure out what looks like. So I think, given all those points, it's pretty obvious. But that's what that piece of it looks like. The vertical asymptote splits the picture into 2 pieces, the left side and the right side. This is the left side. You have it graphed. It's beautiful. Now we got to figure out what's going on the right side. Your options would be this, and I saw some of that on some papers. That's not a good option because what happens right here?
Cross.
And you're not allowed to cross there. You're only allowed to cross at these dots you already put on there. So that option, while it could be an option in some problems, it is not in this one. So the only other option would be here, right?
Can you cross the y-axis when you're doing that? Like if I were, because I
The
did
only
the other
place you
side.
can cross the y-axis is right here.
Okay.
When you plot the intercepts, that's why I have you plot those first. Those are the only places you can cross the axis. That's it. Those are the only times you're going to touch. So now I can answer all the questions. Number 6. What's the limit as x approaches infinity? Well, where are my eyeballs looking? That way. So as the curve's clear up there, but as it goes to the right, what is happening to my pencil? Going up, 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 up. Is it running into anything?
No.
So what's the answer to 6? Infinity. Number 7. The limit as x approaches 0. Now first of all, is there a dot or an asymptote at 0? Where x equals 0, is there a dot or an asymptote? A dot. The y-coordinate's the answer, period. If x is approaching 0, y is approaching 2. I don't care if you're coming at it from the negative side or the positive side. If there's a dot there, if x is 0, y is 2, period. Number 8. Now we're approaching 2. Now do we have a dot or an asymptote at 2? All right, so now we got to pay attention because if I'm an asymptote and you're coming at me from either side, you can't touch me, so what are you gonna have to do as you come at me? You either go up or you go down. So you gotta just pay attention to your picture. We're approaching 2 from the negative side, so what are we doing? Negative infinity. Negative infinity.
You have to specify how much is
If it's negative infinity, it's just you're heading down.
As things are confident.
Yes. You can't approach negative infinity with the box.
Have you missed any yet?
All right, number 9. X is approaching negative infinity. Now, where is that happening? That's happening this way, Mr. Knowles' room. So as I follow my curve to the left, keep going, 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 going,
Infinity?
it's going to negative infinity. But there's nothing stopping it. It's just following this line right down into the basement. Oh, well, we're in the
Negative
basement.
infinity.
Number 10, we're approaching 2 from the positive side. Approaching 2 from the positive side, what's happening? Positive infinity. Now we're approaching 3. Wait a minute. At x equals 3, do I have a dot or an asymptote? A dot. So the answer to the question, whether I'm coming from the left or the right, is simply going to be that y coordinate, right? I don't know what it is, so what am I going to do? I'm going to plug it in. So if I plug in 3, I get 7 times 2, 14. So the answer is 14. And that would be the answer to 12 also, because if you're a dot, it doesn't matter which side you're coming in. You have the same exact result. You're stopping there. Now, speak now or forever hold your peace, because at some point there's going to be a quiz that I'm not going to tell you when. I'm going to drop it on you, and I better have better results than this. Alex? Which one? Number 10. We're approaching 2. Here's where x is 2. We're approaching it from the positive side. What's my pen doing? Where am I going? Positive infinity.
Could the end behavior asymptote ever be a limit?
The end behavior asymptote actually is a limit. I mean, that's how you find it. So what do you mean?
Like, I don't know. If this was wrong, but like x going to infinity, I thought it was x plus 5. Like that was the limit.
Oh, okay. Well, technically it is. But if x is going to infinity, what's happening to x plus 5?
It's staying the same.
No. If x is heading toward infinity, x plus 5 is also going to infinity, right? A little bit bigger infinity? That kind of freaky idea. But, so, no, you don't want to answer with an equation. You want to answer with a number. But yes, you got the right idea. That's exactly right. Now, end behavior asymptotes, do they have to be slanted? Are you going to have like the next time I give you a problem, is the end behavior asymptote going to necessarily look like this? No. Why did this one look like this? Because in the original problem, the power on top was bigger. If the powers had been the same, then your end behavior asymptote would have been a horizontal line. Right?
So will the end behavior asymptote always be referred to as the end behavior asymptote?
We have to now, because before we only had horizontal ones, I would say horizontal, but now we talk about asymptotes that aren't necessarily horizontal.
And it can be either horizontal or
Yes,
okay.
end behavior incorporates horizontal and slant,
Okay.
and anything else. We talked yesterday that if you had an x cubed over an x problem, when you did the division, your asymptote would actually be x squared, which would mean it would be parabolic. You'd have a parabolic asymptote.
Yeah.
So the end behavior asymptote could be anything. Up until yesterday, we've only talked about horizontal ones, but now we know there are lots of other kinds.
If you had in the denominator x minus 2 and x plus 3, Did you ever get that, and how would you divide that synthetically? So
Well-
just say you had an X plus 3.
Well, if this is a squared quantity, then you have to use longer
Okay.
because you can't divide synthetically that way. So, I mean, I'm not gonna give you a quiz like that, but that's what you would do. You would still do the division, it would just be longer division. But only if the top column was bigger than the bottom. So if you had an X squared on the bottom and an X squared on the top, then you're not gonna divide. You see what I'm saying?
Yeah.
Okay, now, those two of you brave souls who turned your papers in, do you have second thoughts? Or are you still good with what you turned in? Still good?
Yeah.
You can have it back.
Yeah, I'll take mine back.
Now, one thing I want to point out is, put that out of way. This is awesome. If you can't get the graph right, you're gonna struggle with those limit questions, right? So you've gotta really make sure that your graphing is up to snuff. Okay, that was tremendous. All right, so now onward and upward. Today we're going to solve some equations. Let's pay attention.
It is 2-7.
I was just, yes, this is 2-7. I was just telling someone the other day that I'm strongly considering not doing all the review that we always do. I'm strongly considering not doing all the review sheets and all that. Because I think what some of you are doing is simply not doing anything until we review. And that's not good. We got to stay on this as we go. So this is a perfect example. Right? I don't think you prepared. Not gonna let me like it. Okay, how do we solve an equation like this?
We get times by X.
There are many, well, I shouldn't say many, but there are at least a couple different strategies. My favorite, and the one I would strongly suggest to you, is simply getting rid of the denominator. So in this case, that would mean multiplying everything by x. So now your equation is x squared plus 12 equals 7x, which is what kind of equation? So we'll get it set equal to 0. And then you can solve it any way you want. This one does factor very handily. So it looks like our answers are 4 and 3. Pretty easy. I do want to caution you about one thing. If you go back to the original problem, the very original problem, you did have an x in the denominator, which would mean that if you had solved the problem and gotten 0 as one of your solutions, you would have to throw it out. 0 is what we call an excluded value. And I think you all understand why 0 is an excluded value. What happens if you put 0 in for x? You get a 0 in the bottom, which is never ever allowed. So with these rational equations, equations have fractions, you got to really pay attention to excluded values. Excuse me. There's nothing wrong with 3 and 4, they're fine. But you can't have, x could not be 0. Now let's try another one, maybe that's a little bit more challenging. attention. Let's make note of our excluded values over here. This time there's going to be two of them. What are they? X isn't going to be able to be what? 1 or 0. So we got to pay attention. All right, I'm just setting that on the back burner.
Why
When
can't
I-
you do one?
What?
Why can't you?
What happens if you put 1 in here? If I get it all solved out and one of those shows up as the answer, I gotta get rid of it. Otherwise, I don't do anything with this. It's just kind of in the back of my mind. All right, any idea on how we might start this? First of all, let's factor this. How does this factor?
X squared.
X minus 1. So if I want to clear every denominator, I can do that by multiplying by what? X and X minus 1. So I am going to go through and multiply everything, including the 0. You got to do both sides of the equation by X and X minus 1. You aren't allowed to multiply some terms by one thing and other terms by another thing. Everything gets multiplied by the same thing, x minus 1. Now, what happens? Well, here the x's cancel out and leave me with this. Here, the x minus 1's cancel out and leave me with minus 4x. And what happens here? It all cancels out and leaves me with plus 2. And since that's a 0, life is good. All right, everybody okay to this point? Now it's a much easier equation, very readily solvable. X squared. So let's collect my terms. What do I got? X squared plus minus 3x. Choose cancel. Is that all I have left?
Yeah.
That factors. So what are the roots to this equation? What are the answers to this equation? 0 and 3. But whoa, what did we say about 0? Can't have it. So the only answer to the problem is 3. Alexis?
Sorry, I just want to make sure I can this is it. So if you're like figuring out what can't be the denominator, and then if that shows up, that's when it can't be
Yep.
against it.
Yep. Because if you had 0 as one of your answers, you'd have a 0 in the denominator. That's not possible, ever. All right, let's try a couple more. How do you want to start this one?
Factor these.
Factor that guy. See what we've got over there. Oh, that's good news, isn't it?
Times everything by those 2 factors.
Times everything by those 2 factors. And I always write them down. I know some of you aren't going to want to do that because you're kind of lazy. But I think if you write it down, you make fewer mistakes because now you can physically do the canceling. Physically do the canceling. All right, here we go. 3x squared. Got another quadratic equation, don't we? Double check my math, is that right? Does that factor? Shooty tooty, I don't think it factors. So what do I do?
Nothing.
Wrong. I gotta use my quadratic formula, yep. Yep, the rules don't change just because the equation looks different in the beginning. We're gonna get a couple of answers here and we gotta figure out what they are. So here we go, negative. What is that? 13. Now, anything wrong with those answers? No, they're fine answers. The only answers that would be bad answers are what? -2 and 1. We are completely fine with those as answers to the equation. Robert?
Would imaginaries work too?
And most likely just not gonna get imaginary.
We are graphing this, so the solutions to imaginary, I mean, if they were imaginary, they would just come out imaginary.
Okay.
Yeah. We're not drawing a picture of it. All right, and then there's this one. Looks a lot like the one we did first. Easy starting, we'll just multiply everything by x. Little bit tougher equation though. We're still going to want to get it set equal to 0. On your test, you guys had something like this, and
No idea how to do it.
you chose to use the quadratic formula, some of you, which of course,
Didn't work.
it's not quadratic. Maybe?
You could.
Oh. Oh, thank you, honey. You're exactly right. Thank you, Katie. And anybody else who was gonna fix that for me, thank you. Yep. It's still not a quadratic equation though, so what are we gonna do? Okay, this is gonna be on the calculator part of your test. So an option you have is to test all your PRRs, none of them are going to work. And then what are you gonna do? After you get done testing all your PRRs, not very many, they don't work, you draw a picture of it, and wherever it crosses the, what? X-axis is our answer. So let's go ahead and practice that. We've done a lot of these, but let's make sure. Oh, goodness. Draw a picture of it and tell me what you see. Just the picture. How many answers are there going to be? 3. This crosses the x-axis 3 times, right? So let's have this group right here. You guys find the farthest left one. You guys find the middle one, and you guys find the right one. And we'll get all of the answers.
Yes.
they matching my answers?
Yeah.
So there will be a couple in tonight's homework where you have to use your calculator. I believe at the end of the assignment. Okay? All right, now we're going to spend 4 minutes and look at section 2.8. Tonight, your homework will be equations, just like that. What I want you to think about now, though, is an equation like this. Or an inequality, I should say. Now, here is what you will be tempted to do. Well, you tell me. How do you think what are you going to do to solve this thing? Multiply both sides by x minus 3. If this were an equals, that's exactly what you should do. But it's not an equals, and you can't multiply both sides by x minus 3. Can you tell me why? What is peculiar about multiplying in an inequality? Grace?
If you multiply by negative, you have to switch this one.
Okay, so tell me about x minus 3. Could it be positive?
Yeah.
Yeah, and if it were positive, I could multiply and everything would be fine. But could x minus 3 also be negative?
Yeah.
And then if I multiplied, I'd have to switch the sign. Do I know what x is?
No.
No. Therefore, I do not know if x minus 3 is positive or negative. Do you see my dilemma? Okay. So what we do instead, you do not, NOT, multiply both sides by x minus 3. You want to do that. You can't. We just talked about why. Instead, you are going to move the 4 to the other side of the inequality. In other words, you want a 0 here, which is kind of a common theme. Think about all the equations we did today. We got zeros every time. Now this is 4 over 1, right? So I'm going to get a common denominator so that I can actually add these two, or subtract these two things. Okay? So what will my common denominator be?
X minus 3.
X minus 3. So I'm going to multiply this by x minus 3 over x minus 3. Now both of my fractions have the same denominator, correct? So I will write x minus 3 on the bottom, that's my denominator, and on the top I have x plus 2 minus 4 times x minus 3. So the two fractions, because they have the same denominator, are now one big giant fraction. Would you agree with me?
Yeah.
All right, so let's clean that up there. Don't forget when you distribute the negative 4, that becomes a positive. So I have negative 3x plus 14. Does that look right? Okay, now, I want you to draw a number line. And I want you to put 2 dots on the number line. 2 open dots on the number line. Anybody want to take a wild guess? We'll pick this up tomorrow. Where those 2 dots might be? 1 to 3. 1 to 3. The other one's at positive 14 thirds. Yep, positive 14 thirds. So we'll finish this tomorrow. Do your homework, get your acts together. Drink out the focus of our life. You have nothing else to worry about except this class.
Yeah. Oh, I bought a shield yesterday. Cool. And then government came back half minute and then left there.
Wait, isn't the exams thing?
It's like the easiest. Pretty good. Yeah, it's not that short.
Okay.
You know, like, yeah, it goes out. It has
Yeah,
like those
I
right on the sword.
have anxiety and basically like my medicine is all of a sudden like stopped working for me, which my anxiety is really bad. Like I don't know what happened. It's just how they do I know, it probably needs hypnosis, everyone. I'm sorry. I'm okay with that.
Can we talk about that for a second? I know, and he calls it really well, this is like, your shoes, like, and he's like, no, let's
Well, I
just do
started
it.
with dance stuff last night though.
I don't know. I had a
And then it was
great work today. I actually got the graph right.
Did you?
And I got some of the limitations stuff. I just didn't get. The only thing that I had trouble with was the behavior asymptote. That was the only thing, and I just guessed it and I got it right. Because I plotted like 10 points.
Oh, good,
This is for,
good.
can my essay be a little longer than a page?
Oh, absolutely.
Okay, great.
Yeah,
I tried to get
everything down at least.
Is it? I know.
Yeah, it's really hard.
It's like, oh my gosh. So, yes, absolutely.
Okay,
And it's
perfect.
single space, right?
No, it's double space. Thank you.
Well, thank you, but I've worn this before, once a week all year, but
Oh,
I'm glad
really?
you like it. Actually, I've got about 10 numbers, so about every 2 weeks. Unless I forget, and then I have to hang the ones I wear in a special place so that I remember I'm wearing them, because otherwise I'd wear the same jumper every day.
Which one's your favorite?
I love all my jumpers. Actually, I have a couple that are my least favorite because I'm claustrophobic, and so if they're hard to get on and off, I've got a back. One day, I can always come to school and work out, and so I'm always not dressed for school. I wear my jumper, and one day I forgot my jumper, and so I have a backup jumper. And just because of all the time, in case I go for my again. But you get one that's hard to get on and off, so. If I have to wear it someday, I will, but otherwise.
She was out.
And I don't, and when I say it's hard to get on, it's not hard to get on. For some of them, I got issues with my hand. I just.
Pretty sure she got me my leg too, but not here. I thought that was the worst one. It hurt so much.
When this is
Cauterize the wounds.
I don't know. Costume classes.
She just wanted to play.
So my jumpers.
Nice socks, by the way.
Thank you. Thanks for bacon.
So that I can put it on now.
I love bacon.
I really like it.
But yeah, my cat was trying to kill me. If I died.
We could do like a sleep.
Yeah, she was like biting me and like trying to play, and I was like, go away.
She's a black cat.
Yeah, me too.
I'm not really on it. I thought you might have been. What's on your face? Disgusted.
Okay. Oh, shoot. That thing's been running the whole time.